Heidi ho, neighborinos. This is episode 7 in our reality show series about installing a grid tie solar power system in our home here in Tulsa, Oklahoma. This is our incoming meter for our 120 240 volt utility service fed off of that step down transformer from our local neighborhood friendly utility company. And if you give me a second, I'm just gonna set this camera here and show you what we installed. That's probably not the best spot. How about right here? Much better. Okay. We have here is a plastic yard storage box purchased from Sears for $109 on sale, normally $150. It was important to get one with smooth sides, both interior and exterior, so that the conduit hubs would mate well on there. Another hardware store had one that had like 1 or 2 inch recesses on the wall of the box, which would not be very good for getting a good conduit penetration for our battery cables. Okay, this is about 50 inches long, about 2 foot deep, a little over 2 foot deep, and about the same height. It locks. That's important that it be able to lock. Okay. We installed a pad. First we cleared the ground a little bit, pulled some of the old plants up, and laid down some plastic. And on top of that we put put cardboard box down first, a plain old folded up flat cardboard box. On top of that we put plastic that the sand came in. We used the bags that the sand came in, and then we had a little bit to start with, obviously. And then we poured sand on top of the plastic and built that up to at least 1 inch to 1.5 inches thick. Other areas it was as much as 2 to 2.5 inches thick. And then we set 16 by 16 stepping stone blocks on top of it, and then kind of trimmed it off with some smaller bricks. The main thing was that it was level, and with the blocks and stuff and the sand that we had left over, we extended it on out. It's not quite as level. It was important that this be level. This not so much. That's more just for decorative, whereas this is more of a functional reason for being there. Anyway, this is our home for our batteries, and I'll show those to you. And I also wanted to show you where the solar panels would be mounting. First of all, as you can see, we've got 1 string of batteries already in place, and we're waiting for the truck to show up at Sears with our 2nd string. We called them about today, and they'll hopefully be in Thursday, in about 2 days. And we also have some handy dandy B-line B22 Green epoxy coated Strut. This is 1 5/8 inches wide by 1 5/8 inches tall, and it's slotted. And we bought 160 feet of that to go on our roof. You're facing north right now in this picture. That is south. And our modules will be mounted on the south roof right here. From the widest point here to that side over there is approximately 54 feet 9 3/4 inches, give or take a foot, and slightly less if you measure from up there at the top where it indents a little bit. I think we're going to have somewhere in the ballpark of 38 feet of rail. There's going to be 3 rows from top to bottom of solar panels, and there's going to be 7 columns. That's not a very good spot to depend. Again, 7 columns, 3 rows. There's going to be 4 rows of Strut, and we have mounting brackets to attach the solar panels to that Strut. The Strut will mount on Durablocks, which is made of 100% recycled rubber, in case I didn't already mention that. and those will elevate the unistrut approximately 5 or 6 inches off the surface of the roof. This roof is just barely 2 years old. Our last roof was pretty bad. Had 2 layers of shingles. This house is built in 1950, and as such it's built a little different than new houses. But the roof material, if you go into the attic, you'll see it's made of kind of like 1x4s, I think, or something close to that, maybe 1x3s. It does not have your typical particle board sheets like the newer houses do. It's a little thicker wood. It's not got any glue in it, unless they treated the lumber with that. And when we had the new roof put in, we had 5 vents added toward the peak. We had a hailstorm a couple years back and caused our ugly old roof to leak. Thank goodness. And because of that, and because the old roof was in such bad shape, we got a brand new roof, thank the Lord, in Allstate. Allstate, you can send your check later. So this is my office behind that window. We plan on putting 2 battery chargers on the other side of this wall inside. There will be a DC distribution box right in their vicinity. The inverter will mount just to my left of these windows on the inside again, and then just to the left of that is a closet in the office, and that's where the fuse box is that is fed out of the main breaker, and the air conditioner compressor is fed out of the other main breaker there, which is perfect for our design, which excludes the air conditioner compressor from our solar system. It just sucks too much electricity to be part of our plan here. Otherwise it would take pretty much the entire project just to run that compressor, and that's not cost effective at this time. So that will be bypassed, which is okay by me because we only use it a few months out of the year anyway. And we'll probably just tie into the existing feed coming out of the other 55 amp breaker that goes into the house, which is perfect. The manufacturer suggests a 60 amp 2-pole on the output, and we have a 55 amp. We'll either stick with that or make some modifications depending on how the design calculations and code review turns out. Before too much longer, I'm not promising you the next episode, but we'll be doing a attic survey to see what we're dealing with from underneath the roof in the attic, besides the boards that I described for you. And for too much longer, we'll be adding our second string of batteries into our enclosure here. It's important to note that you cannot put circuit breakers, lights, or any other active electrical component in this box because it is not a listed enclosure. However, when it comes to batteries, we've not found anything in the code restricting you from putting it in a box such as this. In fact, since this is plastic, it's actually almost a more preferred method since it's fully insulated. If this were a metal box, we would probably have to take extra steps just to add an insulation barrier between the metal and the batteries. We will have battery cables coming into the box through a conduit, and possibly a passive battery temperature sensor. I think I showed you that. It simply is a little 1-inch square pad with a small wire coming off it, and it may stick to the side of the battery, and that'll monitor our battery string temperature. I believe there will be one of those per battery string that will go through its own separate conduit through this wall right here and into the battery charger, and that will monitor our battery temperature and feed that information through the network cable to the inverter, and then through there onto the control panel so that we can monitor a sampling of our battery temperatures. I'm considering possibly some type of vent in the box, even though it's not 100% airtight. It might be nice to have some degree of ventilation And you can even start a fan from the inverter or even the battery charger based on that temperature sensor. If it gets to a certain set point, you can actually program it to turn on your battery fans. But we'll have to be very careful if we go that far to avoid violating any codes due to the, again, unlisted nature of this garden box here. It's basically a garden storage box. It's brand new though, and it is water resistant. That's one of the things they advertise, which is okay by me. And if you look in the part of code that tells you how to store your batteries, it kind of describes this, but it doesn't maintain anything beyond this. So it was either that or build something, which too much money and swearing involved in having to do that, or going with something NEMA rated that was metal, and again, too much money and swearing. So this seemed to be the ideal solution. And that's it for episode 7, and we hope to see you soon.